Okay, I hope I'm audible to all my students who are attending this online lecture for the Mathematics for Business Economics Part 1 course, currently offered in semester 1 of BBE honors at Delhi University. Now, in this particular online lecture, I'm going to start with the discussion of the 2024 question paper, which has come up at Delhi University for the Mathematics for Business Economics Part 1 course. Okay, I hope all students can see the question paper on your screens. So it is a 90-mark question paper, which is to be done in a time span of 3 hours. Okay, just to confirm to all students, this is Mathematics for Business Economics Part 1. BA Honors Business Economics is the name of the course. Okay, so in this particular lecture, I'm going to start with the discussion of question number 1. It says that we need to solve or attempt any 3 parts of the question, but I'm going to solve all parts one by one. Okay, so let's quickly start with the discussion of question number 1, part A in this particular lecture. So let's read part A. Solve the following inequalities. First one is ln x plus ln of x minus 3 less than or equal to ln 4. Okay, so we need to use the properties of logs to solve for this particular inequality. Okay, let me quickly come to the whiteboard and let's solve part 1 on the whiteboard. So I'm just writing the main heading for completeness. This is Delhi University, Exam 2024. Name of the course is Mathematics for Business Economics Part 1. Mathematics for Business Economics Part 1. This is currently offered in semester 1 as per NEP for the course BBE honors. Okay, let's look at question number 1, part A. Solve the following inequalities. I'm writing the first one. The first one is ln x plus ln of x minus 3 less than or equal to ln 4. Now, first of all, we can use properties of logs. Recall that ln x plus ln y can be written as ln of xy using properties of natural logs. I have covered this in depth in my lectures on functions using properties of natural logs. That means if I look at the left hand side, which is ln x plus ln of x minus 3, I can write it as ln of x times x minus 3. So my left hand side, this portion becomes ln of x times x minus 3 less than or equal to ln 4. Now this implies x times x minus 3 should be less than or equal to 4. Okay. Now if you look at equation 1, so I can say that from equation 1, ln x plus ln of x minus 3 is well defined. This term is well defined only when, remember, ln function is well defined only when the domain is strictly positive, only when x, so this is well defined if x is strictly positive, and this is well defined if x minus 3 is strictly positive, which implies x is more than 0 and x is more than 3. So students, what I am trying to say is ln x function is well defined only when x is strictly positive. Ln of x minus 3 is well defined only when x minus 3 is strictly positive. Again, I have covered this in depth in my lectures on exponential and logarithmic functions within the Mathematics for Business Economics Part 1 course. So now I can further solve this particular inequality. So this implies that x square minus 3x should be less than or equal to 4, which implies x square minus 3x minus 4 less than or equal to 0. Now I can use the middle term splitting to solve it further. If I erase this particular portion off, so I got x square minus 3x minus 4 less than or equal to 0, which I can write as x square minus 4x plus x minus 4 less than or equal to 0. I did the middle term splitting. I can take x common in the first term, which leaves me with x minus 4 plus 1 times x minus 4 less than or equal to 0, which gives me x minus 4 into x plus 1 less than or equal to 0. Now, when is the product of two terms negative? Product of two terms is negative if one of them is negative and the other one is positive. So I can say case 1, x minus 4 is negative and x plus 1 is positive, which implies x is less than equal to 4 and x is greater than equal to minus 1. And the second case is, I can write case 2. Case 2 is x minus 4 is greater than equal to 0 and x plus 1 is less than equal to 0. Remember, I am repeating it again. Product of two terms is negative if one of them is positive and the other one is negative. So plus minus or minus plus. So this implies x is greater than equal to 4 and x is less than equal to minus 1. Now this case is automatically rejected. We cannot have a situation when x is greater than equal to 4 and at the same time less than minus 1. Which leaves us with this only qualifying as the candidate. X should be less than equal to 4 and greater than equal to minus 1, which implies x should lie between minus 1 and 4. This is what we are getting. But hang on. Students, you can also see that x should be more than 0 and should be more than 3 also. Then only the function will be well defined. So if I call this as 1 and if I call this as 2, from 1 and 2, what do we learn? I can erase the initial portion off and I can write it on the top that from 1 and 2, x should be greater than 3, but it should be less than or equal to 4. It should be strictly more than 3 actually. Also, x strictly more than 0 and x strictly more than 3 means x strictly more than 3. So x should be strictly more than 3, but it should be less than or equal to 4. That means the answer for this question is that the required interval is 3 to 4, where 3 is not included, but 4 is included. So first of all, we use the rules for solving natural logarithmic functions. Okay. I use them together, ln x plus ln of x minus 3. I just wrote it as x times x minus 3. Okay. I got x times x minus 3 less than equal to 4. I opened up the brackets. I got this quadratic equation. I used middle term splitting. I factorized. I got this. Product of two terms is negative when either the first is positive, second is negative, or the first is negative, second is positive. I took all the cases. Case 1 was x less than equal to 4 and x greater than equal to minus 1. Case 2 was x greater than equal to 4 and x less than equal to minus 1. This case is rejected because you cannot have a situation where x is greater than or equal to 4 and at the same time less than equal to minus 1. That means it only leaves us with this case. This makes it x lying between minus 1 and 4, but x should be strictly more than 3 because the log function is well defined only for a positive domain, strictly positive domain. Ln x is well defined when x is strictly positive. Ln x minus 3 is well defined when x minus 3 is strictly positive. So x strictly positive means x greater than 0, x minus 3 positive means x more than 3. If I club 1 and 2, if I club 1, which is at the bottom in green, and 2, It makes it x line between 3 and 4 with 4 included, which is the required answer. Let's solve question 1 part B. Again, we need to solve the inequality. Which is 2x plus 1 or x plus 3 strictly more than. Now again, if you look at this, it's a fraction. Again, we can take cases. Okay, so case 1. If x plus 3 is strictly positive, so this implies, if I cross multiply, 2x plus 1 is more than 3 times x plus 3. This implies 2x plus 1 is more than 3x plus 9 minus 8. How do I get minus 8? 1 minus 9. 1 minus 9 is more than 3x minus 2x, which gives me x less than 1 minus 9 is minus 8. But this implies that x should be more than minus 3. So this is 1, this is 2. You can clearly see are 1 and 2 possible? Is it possible that x is more than minus 3 and at the same time less than minus 8? Not possible. You cannot have a situation where x is more than minus 3 and less than minus 8 at the same time. So I can write case 1 is not possible. Since x greater than minus 3 and x less than minus 8 at the same time are not possible. At the same time are not possible. And then I can write case 2. Case 2 is that if x plus 3 is negative, which implies x is less than minus 3. Now, if I solve this inequality again, I get x less than minus 8. Let me do it correctly. Let me write it here. So, 2x plus 1 is greater than. So, if x plus 3 is negative, if x plus 3 is negative, I get the sign of the inequality changes, because if this is negative, okay, 2x plus 1 over x plus 3 more than 3. But if x plus 3 is negative, the sign of the inequality will change. So it becomes 2x plus 1 less than 3 times x plus 3. Why am I reversing the sign of the inequality from greater than to less than? Because x plus 3 is a negative term. If I take it on the right hand side, it will change the sign of the inequality using the rules of inequality. So this will make it 2x plus 1 less than 3x plus 9, which makes it minus 8 less than x. So this mark it as 3. Is 1 and 3 possible? Yes. X more than minus 3 and x greater than minus 3. Sorry, this is the case. Let me correct myself. Let me call this as 4. We are not looking at 1, we are looking at 4. Case 4 was x less than minus 3. And then we have x more than minus 8. These two cases together can exist. So I can write from 3 and 4. From 3 and 4, x is more than minus 8, but less than minus 3. This is my answer. So I am repeating how we solved this question. First, I took the case of x plus 3 being strictly positive. So if x plus 3 is strictly positive, then 2x plus 1 is greater than 3 times x plus 3. If I open up the brackets, I get this. If I solve it further, I get x less than minus 8. But from case 1, if x plus 3 is positive, x is more than minus 3. But x more than minus 3 and x less than minus 8 together are not possible at the same time. Then I take the second case, which is x plus 3 negative, which means x is less than minus 3. Okay. Now if I solve the inequality 2x plus 1 over x plus 3 more than 3, I get 2x plus 1. Now comes the change. Because x plus 3 is negative, if I take it on this side, it will change the sign of my inequality. That means 2x plus 1 will be less than 3 times x plus 3, which makes it 2x plus 1 less than 3x plus 9. So that makes it x more than minus 8. Now x less than minus 3 and x more than minus 8 together can exist. You can have a situation where x is more than minus 8 but less than minus 8. Which is my answer for this particular question. So I hope all students have understood how we've understood it. Remember, the inequality gets reversed if I multiply by a negative number. The reason why this became this is because I multiplied 3 by a negative number x plus 3. So I can write a note that the sign of the inequality is reversed. Sign of the inequality is reversed after multiplication by negative number. After the multiplication by a negative number. And in case 2, x plus 3 was a negative number. See, x plus 3 was less than 0. That is why from greater than it became less than when I multiplied 3 by x plus 3. Okay, so I stop at this particular lecture. Remember, students get the maximum benefits when you subscribe to my complete course for Mathematics for Business Economics Part 1. This is just one question we have solved from the past year 2024 question paper. If you really want to get the maximum benefits of the course, you are requested to subscribe to my complete course. Okay, so in the next online lesson, we are going to look at discussion of part B. Question 1 part A has been done. In the next lecture, we look at question 1 part B. So I hope all students have enjoyed this lecture. Any doubts, you can unmute your mic and ask, or you can get in touch with me for doubts on call or WhatsApp, or you can always mail me your doubts at divineschooloфeconomics@gmail.com. This is where I stop in this lecture.